And so now we mentioned before that scientists don't recognize a variable speed sun, but do they recognize a variable distance sun? Yes or no?
But yeah, no, they say it's fixed. They say it's fixed, the sun. So they don't say it's moved. They say it's the earth that moved.
True, but if you go to Wikipedia even, and you put these words in, perihelion, peri and apo. Or actually, I think there's an H here. Aphelion. Okay. Perihelion is the day, and it's perihelion is the 4th of January. Okay, 4th of Jan. That's when the sun is closest to the Earth, according to heliocentrists. This is not flat earthers talking here. This is general, conventional science, consensus science. Okay, based on Copernican, because they had to acknowledge that the sun is always changing its distance to the Earth. At Cancer, the sun is way higher in the sky and more distant to the Earth than at Capricorn, and that's aphelion day. Sorry, that should be July, 4th of July and 4th of January. Now, so just after New Year's Day, when it's freezing winter in the Northern Hemisphere, the sun is closest to the Earth. And heliocentrists say it's 4 million, average 4 million miles closer to the Earth here at Capricorn, aphelion. Sorry, a perihelion. Peri means closest to. Apo means further away. So this is aphelion. And this is perihelion here. Please pay attention, man. And if there's any listeners out there who are still upside down on a Santa ball, pay attention, because your Santa ball teachers who are teaching you everything pseudoscience and upside down and demonic will tell you, because they have to. They can't deny this fact. The sun is further away from the Earth at Cancer than it is at Capricorn. And that's a fact we all share in common, and we can start with that common ground if we want to start talking on a round table and coming to agreement about some of the things. This is one thing that we must agree on, because it is a fact in both models, or in any model. Doesn't matter what model you use. This is a fact. And you can only, I believe, and know, you can only explain the variable distance sun and variable speed sun like this. There is no other way. There is no other way. It doesn't work heliocentrically, doesn't work when the sun's 93 million miles away. It just doesn't work.
Now, that brings me to another question that I have. Could the sun be further away than what flat earth model people tell us? Because it doesn't make sense, really, that the sun is only 3,000 miles up in the sky. When I look at it from here, my viewpoint, and even the speed doesn't make sense to my eyes. Like, I would see it, like if a jet, if I'm on the ground, I see a jet airplane coming from far, I cannot notice the speed. I just see it coming. But the moment it passes over my head, I'm going to hear it. Phew, it's going to fly. I'm going to notice the speed. So why I don't notice the speed of the sun at 800 miles an hour in front of my face when it's right in front of me? But it's very, very slow. I notice so this is the problem that I have, matching that speed with my visual observation. I'm very mixed up in all this.
Yeah, well, this is because this is our perception. Unfortunately, our perception and the bending nature of light. Light For a start, there are no particles, and there are no particles traveling at all in a direct line. What all magnetic light is curvilinear, okay? It's all curvilinear. So when it comes out of the transit, let's say this is the center, this is the, well, let's put the Earth here where I put it, eh? The Earth, here is the Earth's transcendent point. This is counter space. And so from here, everything in our solar system comes from here. And there is another argument that says everything in the solar system comes from the center of the sun. Well, I think it's both. It's this torus field here, paradise, the Garden of Eden. This is the material center of the universe, the Malkuth, the Earth plane. Okay, so what happens is this energy, as the creative energy comes out and goes this way and that way at the same time, there's your sine wave, right? As it does that, this all-knowing transcendental point knows how much to exert its energy so that it reaches this point. Somehow it knows its Tropic of Cancer, and all waves first diverge centrifugally, and they will hit their top where the maximum of their energy can be extrapolated in one divergent direction. Once it hits that point, it then has to converge centripetally, and then the energy is always reclaimed. It's always returned to the source and recycled yet again. And this is how all cycles work. All cycles work like this because all things are magnetic, and this is how magnetism works in torus fields. Okay, so your question was the sun, how it's very hard to, it looks like it's moving really slow. Well, yeah, this is it, because, well, the sun, who knows, it might be 8,000 miles high. It's within the 10,000 mile range, depending on where it is here. I'm sort of leaning towards the 3,000 mark here at the equator, and probably 4,500, 5 up here, and 2.5, maybe 2,000 here.
It varies in altitude.
Yeah, we'll see. Well, if that is too hard to fathom, that the sun could be 3,000, let's make it 3,000 here, 4,000 at the top at Cancer, and 2,000 down the bottom, all right, for argument's sakes. Well, that's only a variable of about 2,000 miles, whereas mainstream conventional science give you 4.5 million miles.
Yeah.
So when you reduce the scale, you realize what's going on. It's more in this range here, obviously, because that discrepancy of distance, it has to be factored in. The fact that the sun is variable height must be factored into all models. It doesn't matter which model you're going to use. And so you can't escape this. And you cannot escape the fact that the sun is variable speed. Now here is how the mainstream academics, precious academics, will tell you that the sun is variable speed, because they say that all orbits are elliptical. Elliptical? So what's an elliptical orbit? Well, it's an orbit that is not perfectly circled. So it's more like an egg, yeah? Like that. Now, so they say the moon has an elliptical orbit around the Earth. The sun, the Earth's orbit around the sun, they say, is elliptical. Therefore, so if the Earth is going around this away, around the sun, there's the sun in the middle, and the Earth is in an elliptical orbit, which all orbits are elliptical, all of them. Well, we see, you'll understand why they're elliptical, because they're all conical, they're all in cones. It's not that they're traveling around in a football oval shape. No, it's because they are sections of a cone. So if you've got a cone like this, everything is conical in energy, and something is going around. Well, that's, you see, as it goes, there's always a disparity in the angle of its action. Well, see, that's an oval, that's elliptical, and that can be explained on flat Earth quite easily. But this is the point. If they're saying that all orbits are elliptical, well, then it must be faster here, we must be going way faster past the sun here at, say, this will be what they call Aries and Libra, the equinox, maybe. And here will be, well, no, actually, it's like this, actually. I've done that wrong, because they always put the main body sort of not in the middle here. They put it over to the left. So this will be summer, this will be winter, and this will be the equinox. Okay, so if that's so, well then, by their own teaching, by their own doctrine, and their own elliptical orbit nonsense, they are telling you that the sun is variable speed. It has to be.
Has to.
Okay, so but how they get away with it is through relativity, and they will say that the Earth is variable speed. Okay, well let's go along with them. Okay, let's humor the scientists. They'll say, well, the sun's not actually moving, although it's hurtling around the center of the Milky Way galaxy at a bazillion miles an hour, blah, blah, blah. It's actually the Earth in an elliptical orbit around the sun. Well, if that's so, then the Earth is a variable speed Earth. It has to be. If it's on, because when you go around here, you got to go slow. This is slow going. Here it's fast going. Slow, fast, slow, fast, slow, fast, slow, fast. This has to be fast here. It's like you said, when an aeroplane goes over your head, you hear the Doppler effect. Yeah. But it wasn't speeding any faster. It was always traveling at that distance. It's just that near your vicinity, it appears faster. It's not real faster. It appears to be faster. And that's your limited perspective and hearing, which causes you to limit the whole thing.
That allows me to perceive the sound and the effect of the speed also, but I should perceive the same thing from the sun. This is what or either it's very, very high, that it's very high, we cannot perceive the speed that it's going to. Like, I mean, I don't know, when I see a plane in the sky, it's the same thing. It's the same thing with the plane. The plane are traveling at 500 miles per hour, but you don't see them going that fast. They don't seem to go that fast. And especially when they take off on the track, like if I go at 100 kilometers an hour in my car, it's much slower than what the plane is taking off. But I don't see it's hard to intellectualize the speed that the object is going at. This is what I mean.
Yes, because you don't have any markers up there, like say 1 mile markers up in the sky to show you against the aeroplane to see how fast it's actually going against those markers. It's like just a big blue sky, and so you can't tell. And so this is why I wouldn't be physically chasing the sun as actually a ball. I would be positioning myself to follow its apparition, its projection, like a rainbow. If you move too much, you'll miss the rainbow, and the people just standing there 50 meters away, they will see the rainbow in its full glory. You're standing in the wrong spot, you can't see it, but it's there. They see it. It's just that your perspective, from your vantage point, you cannot see it. And so these are the tricks that we do need to trust our senses, but not fully.
You know, another thing I want to bring up is the ball earth. Okay, if we take the ball earth model, even if we go to the ball earth model, it's so perfectly arranged and made together that I highly doubt that it comes from one single guy or a bunch of guys united together like Copernicus and his friends to come up with the globe model. I think it's much more, even if you take the globe, all the knowledge about it and everything, it's much more divine than a bunch of guys with Copernicus putting that up together. Do you agree with that? Or I think there's higher intelligence even for the designing of all that, because look, we're all thinking that we live on the ball and we're monkeys. There's something that they have done. It's so perfectly arranged and everything matches. Like, you take the number of all the numbers that we have, you put them on the globe and it works. You put them on a flat plane, it's very hard to. Anyway, I'm not saying that we live on the globe. It's not that. But.
Yeah, Nick, when you were saying that, like I remember. I think it was the last time we were talking, you said, I mean, the earth obviously isn't completely flat. Like, you're going to have mountains and all that, from one end to the other. Obviously, Pilote LX there, from his perspective, he's going to be, from that high up, you're going to see it's just straight, How can you deny from that position he's in the sky, seeing, you can literally see a straight line. It's just, no matter what, it's not going to be perfectly flat though either. I mean,
but he wasn't in denial. He was not saying that he lives on a globe. It's not that, but it's just that we were analyzing stuff and we were like, okay, look at it for sure. Just like the gyroscope inside the plane tells you you're on a plane, and even when you go up, it will always show a flat surface. Like, I don't know. It's just very confusing.
Obviously, perspective, but if it appears to be flat when I look at that. I mean, some people say, "Oh, you could clearly see the curvature," and do you though? I think people are just kind of in denial. It looks like a straight line.
But I think all that pseudoscience or science, whatever you want to call it, I think it comes from even probably higher intelligence. Santos, what do you think about that? Even if we take any stuff that we know here, the language, the numerology, the everything, come on, I don't know. I think what do you think about that?
Well, look, it's all about the elite and what they have manufactured as our reality. It's not about we have inherited a true, honest system and we can trust it. It's not like that. We think it's supposed to be like that. But for instance, 500 years ago, before Copernicus and the Jesuits who created the globe, everyone knew the world was flat. They didn't believe it. They knew it because back then there wasn't so much tampering and there wasn't so much need for there to be a globe for globalism, global governance, global currency, global economy, global religion, which is what the Jesuits have been working towards for about 4,500 years. Okay, 450 years since 1543. That's all they've been doing, creating a world that is on a globe so that they can have their global religion, Catholicism, global economy, which is their central bank system. They own it. Global governments, which will be Rome, DC, and London. And we know that they already have global warming and global this and global that, all sorts of nonsense. The people who did that, what they did was they had to destroy the credibility of all the ancient teachings. All the ancient teachings all taught that we lived on a horizontal plane, okay? And they did not recognize the earth to be a ball. They knew it was round, and circular? Yes, it's circular, but not spherical. So if we look at a little coin here, so if that was a table, a round table, you wouldn't say that that was spherical at all. It's flat. It's so when you, no matter where you are, and you're on a flat surface, you will always see that flat surface, if it's bigger than your eye range, as circular. Even if it's a rectangle, the Earth could be rectangularly flat, square flat. It doesn't matter. We'll never see it because we're not high enough, and we'll never have the perspective. Our eyes, the range is only about, what, 4,000 or 5,000 miles. And so as we look around on the flat, round Earth, everything appears to be round. What they're seeing is rotundity. They're not seeing fall. It's not fall. They will never see any fall because it doesn't fall away. So if you're going to have, say, I'll grab a plate. So if you're see this, that's how the Earth is. It's like that. In Revelation chapter 21, it calls the Earth a platos, which comes from the Greek verb platus, which means plateau, which means a plate. And that's how the Bible is described. In another scripture, it says the circle of the Earth. Never says the sphere of the Earth. The Bible never says that because it's not a sphere. And so if you go up in an airplane up this high and you look down here, what you will see from that height is you will see this curvature. You're seeing rotundity. Okay, you're not seeing that curvature. So if you're on the other hand, if you're on a ball and you go up high like that into the atmosphere on a plane, well, as you look in front of you, you should be able to see that fall there. That you'll never see. Never, ever. It's never been witnessed by a human being. So this is how stupid they are. And they'll argue this. Oh, I've been in a plane 45,000 miles, feet high, and I saw the curvature with my own eyes. Well, yeah, you saw that curvature of the plane disk Earth. You didn't see that curvature because when you look out the window of your aeroplane, you can see the horizon at eye level. Doesn't matter how high you go. And you look around, all around 360 degrees, and the horizon does not fall away anywhere. It's right at your eye level.
Yeah, but from that viewpoint, you cannot see the roundity of the Earth, because if not, you would see the edge of that flat Earth. If you would see the roundity, what you see is the flat horizon, because that's as far as you can see, I guess. Then.
Yes. Right? They see the flat horizon. It's like if I'm looking here, I see there'll only be a flat horizon, but you'll see the end here is curving back to you, and this curvature here, they think it's falling that way. It's not. It's not falling downwards, it's falling back. So from your perspective, like for instance, if you look down the road, you'll see that let's do this, shall we? So if you're looking down the road, there's the road there, and you're standing here, you're looking down that road, and so you've got so let's say there's TV poles here, electrical poles. All right, so they're along the road, and so what's happening is you see all of this goes down, right, as they get further away from you in the distance. Now, this electrical pole here is not shorter than this one. They're the same height, and the road is level, like all railway lines. They're all level because trains can only go on level, right? So, but what you're seeing is So if you're on a big round Earth, right? Sure, like you said before, you can't see the edge of the Earth. So how is it that you see any kind of rotundity at all? Well, that's how your eyes work. Your eyes are round, and they look around. They don't look a square. So everything, the eyes will always see roundness. You'll never see a portion that sticks out more than your eyes. You know, the reach of your eyes, or your sight's ability, the range. You won't go past that range. It'll always be circular.